Hello friends, welcome back to your UPSC. Today we will start with biogeography and our first topic in biogeography will be soils. So let's get started. Soil. Soil is actually upper layer of mantle rock, or we can say loose material on the mantle rock consisting mainly of small particles. Okay. So the top layer of the mantle rock, which consists of loose materials or very small particles, is known as soil. Okay. Now, naturally occurring soil is influenced by parent material, climate, reliefs, and the physical, chemical, and biological agents in it. Okay. Now, the soil, it mainly consists of mineral particles in a certain proportion. Okay. And decayed organic material, soil water, soil atmosphere, and living organisms, which exist in complicated and dynamic relationship with each other. Okay, so in a soil, we can see all the physical, chemical, and biological features. Okay, like chemicals. Okay, then we have minerals, and then we have organic materials and various microorganisms present in the soil. Okay, now starting with the parent material. Parent material includes both hard, resistant rocks such as granite, slates, etc., and also less resistant, or we can say soft and non resistant rocks such as recent volcanic lava, ashes, and most of the sedimentary rocks like sandstone, clay, silt, and limestone. Okay, the term rock is strictly applied not only to granite, sandstone, and the like, but also the gravels, clays, and unconsolidated sand. So here, rock, it does not only signifies these rocks, but also like clay and other materials. Okay. Now, looking into soil components, soil is basically made up of inorganic material, which are also known as mineral fractions, then organic materials, then air and water. Okay. Now, each of the component is important and necessary. Okay. Now, their composition is different in different layer of soil. Okay. Now, like in top layer, we will have organic materials more, and air and water will be more. Okay. But sorry, air will be more. Then air will decrease when we will look into the groundwater level. Okay. So the layer above it will have quite good amount of water in it. Okay. And it will be more having more of inorganic material. So likewise, with different layer, the composition of these elements, these four elements, it differs. Okay. Now we will look into basic classification of soil. So soils is basically classified into many types on on various bases. So we'll classify the soil one by one. Start to classify soil on the basis of its texture. Soil is generally classified or characterized by the size of its particle. Okay. So here we will classify the soil on the on the base of particle size in four types. That is sandy soil, clayey soil, silty soil, and loamy soil. Sandy soil. This is the most coarse soil among all. Okay, it has biggest particle size, and the size of particle range from 0.2 to 2 mm in diameter. And this soil being very coarse and having big particles, so here what happens is the water, it drains away and it penetrates inside, and along with it the minerals present also drains. Okay, that's why this soil lacks humidity as well as nutrients. Okay, so humidity and nutrients are not present in this soil, and hence this soil is known as hungry soil. So this soil is basically not good for crop crop plantation. Okay, as it is basically used for growing bajra, then groundnut, then legumes, and it is good for horticulture, like vegetables and fruits can be grown. Then next we have clay soil. Clay soil has exceptionally fine grained soil, is exceptionally fine grained soil. It has very fine particles whose size is 0.002 mm. Okay, so firstly this soil was, that is sandy soil, was quite aerated but it lacked moisture. Okay, but clay soil, it contains less of air but its humidity retention capacity is quite high. Okay, and because its humidity retention capacity is quite high, it forms sticky mass, which when completely dries out, it forms hard concrete like surface, which is very hard to plow. Okay, and even when it is wet, it is very hard to plow. This clay soil, it is often rich in plant food and gives better yield than the sandy soil. Okay, so this soil is basically devoted to uh, production of rice, perennial grasses, and clover. Okay, then we have silty soil. Silty soil actually, its particle size range between clay soil and sandy soil. Okay, so its particle size is 0.02 to 0.002 mm in diameter. Okay, now this soil is rich in humus content and is devoted to numerous cereal and non-cereal crops. Okay, so it has got good quantity of air as well as good quantity of humidity, so it is good for plantation of crops which are non-cereal as well as cereal. Okay, lastly we have loamy soil. Loamy soil is highly fertile soil which consists mainly of mixture of sand and clay together, and along with it, it has silt and humus content in it. Okay, it has good quality of both sand and clay, but not their bad qualities. Okay, so it contains their good quality, like it is quite aerated as well as it has good water retention capacity. Okay, and other thing is it has silty soil in it as well as it has humus content in it. So there is almost equal mixture of sand and silt in it, but 30%, less than 30% clay is present in it. Okay, so it is generally devoted to wheat, barley, legumes, sugarcane, etc. So this was the classification on the basis of texture. Now we will look into another classification, that is on the basis of pH level of soil. Okay, so on that basis we can classify soil into acidic soil and alkaline soil. So how can we classify the soil on the basis of its pH level is, see, a soil solution contains may contain a significant amount of hydrogen ion, that is cation, which stimulate acid formation. Okay, so H positive ion, it stimulates acid formation, and when acid is stimulated, the soil become acidic. Okay, then we have, if the on the other hand, if OH negative or soil has high basic cations, that is high basic ions, that is anions. Here it is, cations. Okay, so when it has anions, the soil is basic or alkaline soil. Okay, and this acidity and alkalinity of soil is expressed on the pH scale. Okay, so how on pH scale? See, we have pH scale which ranges from 0 to 14. Okay, and in the middle we have 7, and 7 is neutral. So when the pH level, pH reading goes below 7, the substance is said to be acidic, and when it goes above, the substance is said to be basic or alkaline. Okay, so this is how the soil is classified into acidic and alkaline soil. Now we can classify the soil on the basis of porosity. So on the basis of porosity, as we have studied earlier, we have clayey soil and sandy soil. So they are of two types, that is porous soil and non-porous soil. And so porous soil is like sand, and then we have non-porous soil like clay. So these are two extreme ranges, but we have two more soil in between them, that is silt and loamy soil. Okay, so these are various classification. There are other classifications also, like on the basis of chemistry of soil, on the basis of color of soil, but these are basic classifications. Now we will look into soil profile. Soil profile. Soil profile actually is a vertical section of soil in which all the soil horizons are shown. Okay, so a vertical section of soil, like if we cut the soil vertically, and we can see all its horizons, okay, all its layer. So this is known as soil profile. Okay, and what actually our soil is soil horizon? We can easily say that soil horizon is layer exposed in pedon. Okay, or we can also say a layer of soil which lies more or less parallel to the surface and has fairly distinctive soil properties is known as soil horizon. Okay, so most of the soil profile, they include three master horizons, and soil profile actually extends from surface to the deepest extent of the plant root. Okay, or we can say to the bedrock or regolith area. So from top to bedrock. So the three master soil horizon are O, A, and E. Okay, so O horizon, also known as organic horizon, it is denoted by capital O because it contains organic material. Okay, so it overlies the mineral horizon, and it is formed due to accumulation of organic material derived from plants and animals. Okay, then we have A horizon. A horizon is the topmost or uppermost mineral horizon. It is rich in organic material consisting of numerous plant root and downward humus from the organic horizon above. And then we have E horizon. E horizon has clay particles and oxides of aluminium and iron. But these all things in E horizon, they are actually washed away by the water, penetration of water, seeping of water inside. Okay, so left behind an E horizon is pure grain of sand and porous silt. Okay, so this is having organic material, basically humus. This is having minerals and some organic materials from the top layer. E horizon, it has aluminium, iron, but these all things are removed by seeping of water, and because of it, E horizon at last it has silt, porous silt, and sand. Okay, so these are three layers till where the plant root ranges, and these three layers they consist in soil profile. Okay, the other layers are B layer, C layer of the soil. Okay, so the B layer, it receives clay particle, aluminium and iron oxide, as well as some organic material washed away from downward from A and E horizon. Okay, then we have C layer. C horizon is actually, it is not considered as a part of soil, and it consists of parent material matter of soil. Okay, so this was the layer of soil or soil horizon and soil profile. Now we will look into major type of soil. So soil is basically divided into three major types, that is zonal soil, intrazonal soil and azonal soil. So zonal soil is a soil which is characterized or whose characteristics are dominated by the influence of climate and vegetation. Okay, and these soil occur on gently undulating land where drainage is free and where the parent material is of neither extreme texture nor chemical composition. Okay, so they are further divided into felt pedelfers and pedicles. Okay, then we have intrazonal soil. Intrazonal soil is actually the soil which has been influenced in its development less by climate and vegetation than by other local factors such as defective drainage, excessive evaporation, or unusual parent material such as limestone, etc. Then terrain and ages. Okay, so these soils are basically divided into three types. So first is calcimorphic soil, then we have halomorphic soil, then we have hydromorphic soil. So these are basically three types of soil in intrazonal layer. Then we have azonal soil. Azonal soil is a soil which has been, which has not been significantly subjected to soil forming process of the development of a mature profile. Okay, so there is little change from the parent rock material in azonal soil, and it do not have B horizon because it is very immature. Okay, so here the development has just started. So it is actually basically divided into three types, that is lithosol, regosol and antisol. Antisol is also known as alluvial. Okay, so in zonal soil we can see various soils such as tundra soil, Arctic brown soil, podzol, grey brown podzol, brown earth, or brown forest soil, etc. etc. Okay, then we have intrazonal soil. In intrazonal soil we have red desert soil, we have meadow soil, we have fan peat soil, then we have bog peat soil, dry peat soil, etc. Then lastly in azonal soil, like we have mountain soil, alluvial soil, marine soil, glacial soil. So in it we have riverborne material, salt, till soil, then we have limon soil and recent lava and ash soil. Okay, so these are three major type of or three major soil type. Now we will look into major soil classification and distribution. So soil classification is basically a cumbersome task, and there are numerous classification systems which are used worldwide. Okay, so we have like US classification system, we have Canadian classification system, and various other classification system. So on the basis or basically we divide the world soil into these 11 type of soil. So first we have oxysoil. Oxysoil is also known as tropical soil. Oxysoil soil is largely confined to hot and humid climate of equatorial region, and because of immense temperature and persistent moisture and almost uniform day length of equatorial latitude, the soil is greatly affected. So the soil has a distinctive horizons with a mixture of iron and aluminium oxide. Okay, so these type of soil, they have or they are found in equatorial and tropical rainforest, and here because of their growth of plants, the luxuriously huge amount of humus content is added to the soil. Okay, so these soils are basically found in Malaysia, Thailand, Indonesia, Brazil, and all the equatorial region. The oxysoil soil is generally reddish and yellowish in color because the humus content in it is leached under the impact of heavy precipitation. Okay, then the lower layer of soil or the subsurface horizon in oxysoil soil is highly weathered, which contains iron and aluminium oxide, and these layers are subjected to repeated wetting and drying. So that's why the sublayer, it forms hard soil layer. Okay, and these soils are basically used for luxurious cultivation of rubber, then other crops, hardwood plants are also grown here. Okay, like we have teak, sal, etc. Then we have aridi soil. Aridi soil is also known as desert soil. It occupies 19.2% of the Earth's land surface, and these type of soils are confined to dry region of the world. Okay, these soils have pale light color. They have pale or light color. They are moisture deficient, and generally inadequate soil moisture is not suitable for the growth of plant, so there is lack of growth of plant. Okay, it has high potential of evapotranspiration, and due to low precipitation there is low produce in the soil, and this soil has very shallow soil horizon. Okay, it also lacks organic material. As I've said that these are found in the dry regions, so it will be found in desert and semi-desert or semi-arid regions of the world. And this soil is basically characterized by salination because of excessive evapotranspiration. But in some areas like in Nile, Indus Valley, and Ganga River Valley, this soil are intensively cultivated. But we have this soil because of careless management of irrigation water. The aridisol soil in various areas it is rendered useless. Then we have mollisol soil or grassland soil. This mollisol soil contains large humus content and they are some of the most productive soils in the world. Okay, the surface layer of these soils is dark in color because of huge amount of humus content. They are soft even when they dry out. Okay, they have granular or crumbly texture. Okay, so they are fertile soil. Okay, they have quite a balanced amount of air in them, and they have good amount of moisture content in them. They are between humid and arid soil moisture. Okay, so the soil moisture is between humid soil and arid soil. So that means they have good amount of moisture content. So soil of steppes, prairies, pampas, velds, downs, they belong to these soil groups. Okay, and these soils are found in like Manchurian grasslands of China, Ukraine, Russia, and Europe. Okay, agricultural range is large scale commercial grain farming is also done here, and grazing along the dried portion where they are found in dry areas. So along the dried portion of the world, these soils are used as grazing lands. Okay, pasture land. Now next we have alfisol soil, which is moderately weathered forest soil. It is most widespread of all the soil order and extending from near equator to high latitudes. Okay, they are pale grayish brown to reddish color, and they are considered moist version of the mollisol soil group. Okay, so the mollisol soil group, its moist version is alfisol soil group. Okay, so the alfisol soil group are fertile depending on the availability of moisture and temperature. Okay, so the soil is usually supplemented by moderate application of lime and fertilizer in the area of intensive agriculture, and in subtropical and tropical latitudes they are devoted to the growth of grapes, almonds, walnut, fig, olive, and other citrus fruits. Okay, next we have Altisol soil, which is highly weathered forest soil. It is found in subtropical forest, which are highly weathered, and they are reddish in color because of residual iron and aluminum oxide in A horizon. Okay, so they have iron and aluminum oxides. Okay, so because of increased precipitation in Altisol region, they have great mineral alteration and they have more of leaching, and therefore the lower base level of basic cations, that is having calcium, potassium, and manganese. Okay, so they have low level of basic cations, which leads to their infertility, and the fertility of this soil is further reduced due to certain agricultural practices. Okay, the because the effect of soil damaging crops like cotton, tobacco, they are grown there, which depletes the nitrogen content because they are so the crops like cotton and tobacco, they actually takes away nitrogen from the soil, and here the people do not grow leguminous plants, okay, which fix nitrogen, okay. So that's why nitrogen content is also lower down in the soil, because of which the soil becomes more infertile. But if we do some practices like crop rotation and good soil management, then the soil can get much suitable for agriculture. Okay. Next we have spodosol soil, which is in which is northern coniferous forest soil. This soil is found in cold forested wet areas. That's why it is known as coniferous vegetation soil. Okay. So these soils are mainly found in North America, in northern USA, northeast Canada, Eurasia, Siberia, Denmark, Netherlands, eastern Sweden, Finland, and other southern England area. Okay. And because there is no comparable climate in the southern hemisphere, so these soils are basically found in just northern region. Okay. So the soil forms from sandy parent material, okay, which is shaded under evergreen forest of spruce, fir, and pine. These soils they lack humus and clay in A horizon, which is white horizon. So the A horizon it consists of sandy and leached clay soil, okay, and has iron content in it. But over this, we have a horizon which consists of evaluated organic material and iron and aluminium oxide. Okay, so surface horizon it receives organic litters from poor and acid rich trees. Okay, which contribute in acid accumulation in the soil. These soils are ash gray in color and they are good for agriculture if possible only if nitrogen, phosphate, and potash are added to the soil, and scientific rotation of crop is adopted by farmers. So this was spot soil. Then we have anti-soil soil. Anti-soil soil is a recent undeveloped soil in which vertical development of horizon is missing. They occur in many climates. Anti-soil are true soil that have not had sufficient time to generate the usual horizon. And from agricultural point of view, anti-soil soil are generally poor, although the one which are formed from river silt deposit are quite fertile. So these soils are found in active slopes, alluvial filled floodplain, and poorly drained tundra, tidal mud flats, and sand dunes, etc. region. Okay, so they are found in these eroded region, the area where the erosion and deposition takes place. Okay, so like we have floodplains, so here the deposition will take place. So the recent deposition forms anti-soil soil. Then we have incapti-soil soil, which is weakly developed soil. So these incepti-soil soils, they are actually infertile and they are weakly developed young soil, but they are more developed than anti-soil. Okay, they are they include wide variety of different soils, all holding in common that is lack of maturity with the evidence of weathering, just beginning part of weathering. Okay, so the weathering has just started. These soils are associated with moist soil regime and have no distinct alluvial horizon. Okay, they include most of the soils of Arctic tundra and glacially derived tills and outwash minerals of Siberia, New York, and alluvium of Mekong, Irrawaddy, and gangetic floodplain. Okay. Then we have andesol soil. Andesol soil is formed from volcanic parent material. Its name is derived from Andes mountain. Andesol soil occurs in the area of volcanic activity, obviously. These are derived from volcanic ashes and glasses. And the andesol soils of Hawaii are well known for their high yield of sugarcane and pineapple. And because they are derived from volcano, okay, the volcanic parent material, they have small aerial extent. Okay, they are mainly found in the areas of Ring of Fire in the Pacific Rim. Okay, then we have vertisol soil. It is actually expandable clay soil. It is heavily clay soil which consists of more than 30% of swelling clay, okay, which swells significantly when they absorb water. Okay, so they are located in the region which experience highly variable soil moisture balance through the season. Okay, these soil occur in the areas of subhumid and semi-arid moisture and the moderate to high temperature areas. Okay, these vertisol soils, they are frequently formed under savanna and the grassland vegetation of tropical and subtropical climate, and they are sometimes associated with distinct dry season forming a wet season. Okay, they are black, and when wet they are black, and their color, it ranges from brown to dark gray. Okay, so as we have seen that they swells when they absorb moisture and they shrink down when they dry up. Okay, and when they dry up, vertical cracks are developed which widens and deepens as the soil dries. Okay, and some deeps are actually 40 centimeter deep. Okay, these cracks are sometimes 40 centimeter deep, and their size, it range from the size of the cracks, it range from 2 to 3 centimeter wide. Okay, these vertisol soils have high base and nutrients, and thus are better farming soil whenever they occur. Okay, so whenever they are used with other soil, they are mixed with other soil, they are very fertile soil. They are found in Deccan Plateau, Madagascar, Mozambique, Namibia, eastern coast of Brazil, etc. And these soils are generally utilized for the cultivation of cotton, millets, maize, etc. Lastly, we have organic soil, that is histosol soil. Histosol soil are formed from accumulation of thick organic material. They are found in mid-latitude when the conditions are favorable. The bed of the formed lake, they turn into histosols. Okay, when the water is gradually replaced by organic material to form a bog or a layer of peat. So the histosol soil are developed in small, poorly drained depressions which contain sphagnum peat to form these soils. Okay, so they contain. Okay, so here these dry peats which are formed from histosol soil. Okay, they serve for centuries as low-grade fuels, and they are found in the areas of southwestern areas of Hudson Bay in Canada. It is a typical histosol formation area. So these were the classification of soil and its distribution. Lastly, we will look into soil erosion. So soil erosion is basically removal of the soil at the greater rate than its replacement by the natural agencies like water, wind, glaciers, etc. So this fast removal of soil is known as soil erosion. Soil erosion occurs without intervention of human activities, but later often accelerated by the natural processes. Okay, so soil erosion may be divided into four main types, that is wind erosion, sheet erosion, rill erosion, and gully erosion. Wind erosion is actually the wind, it removes dry, unconsolidated material. So, wind erosion is a serious problem in arid and semi-arid areas. So, the main remedy of wind erosion has been to keep as much of land as possible covered with vegetation, that is cover crop. And another method is planting long line of trees as windbreakers. Okay, so this is like area, the land area. So here we will plant a long line of tree. Okay, so they will act as windbreaker. Then we will, here also we will plant trees. So these long line of trees, they will act as windbreakers. So the wind will slow down and it will not be able to erode. Sorry, its velocity will not be that much that it will be able to erode the soil or top layer of unconsolidated soil. So so the wind erosion is quite a serious problem in almost entire arid and semi-arid region, like we have state of Rajasthan, Western Haryana, Southern Punjab, Northwestern MP, then we have Marathwada in Maharashtra, which are seriously affected by wind erosion. Then we have sheet erosion. Sheet erosion is widespread removal of surface debris. It occurs because of overland flow on the low gradient slopes, and they are generally in relatively slow speed and over a longer period of time. Okay, it comprises of two processes. First process where the raindrop they impact, and second is overland flow. Here the sheet, they are washed away, carrying away the particle by the falling rain or by the sheet. This type of removal or this type of erosion is widespread in humid region. Then we have rill erosion. Rill erosion is basically removal of surface mineral, usually soil, by the action of running water. So this process, it creates numerous tiny channels. So this is like an area. So here the running water, it will make tiny channels. These channels are known as rills. Okay. So the running water, it forms rills or tiny channels. These are known as rills. Okay. And this type of soil erosion is localized erosion, and it is developed in humid climatic condition. Okay. Lastly, we have gully erosion. Gully erosion takes place when the stormy rains they are produced, and there is a concentrated runoff, thereby removing soil and other poorly unconsolidated sediments. The main cause of gully erosion is the removal of vegetation, particularly of trees, with its widespread binding root. Okay, so trees actually what they do is they actually bind, their roots actually are like they're fibrous. Okay, so they bind the soil. So when the water flows, water is not allowed to take the soil, much amount of soil, because the roots of the tree are they are binding the soil. Okay, but when the trees are removed, the binding is also removed, and this area it becomes free, and there is no binding. So this area, the soil become loose, and water it takes away the fertile layer of soil. Okay, this problem of gully erosion is widespread in Chambal River in India. Then we have Tennessee Valley in USA, in Italy, Greece, Cyprus. also we can find such type of problem. The maintenance of effective vegetation cover can reduce the development or the process of gully erosion, and the improved agricultural practices are also necessary to overcome this problem of gully erosion. Okay, so these were the basic type of erosions and their remedial measures, and with this we complete the topic of soil. That was all for today, guys. I hope you enjoyed today's lecture. So let's meet in our next class. Till then, take care and have a nice day.